today's session. Today I will discuss some important short questions on electrostatic fields and conductors and capacitors. Actually, this topic is based on the electrostatic fields and the what is the field, what is the conductors and capacitors. In your syllabus, it is about the Unit 1 and Unit 2. Myself, Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering in IARE. Now, first question what I will discuss today is define the dot product in the vector analysis. So, dot product in first, what is the vector? Vector is if any quantity or any measurable thing has the direction as well as magnitude, we will call it as a vector. So what is vector analysis? If any topic has the magnitudes as well as the direction, then we will tell it as the vector analysis. So what is the dot product? Actually, while we are doing the vector analysis, we can do any algebraic function on the vector. So while we are doing the multiplication of vector, it is basically two types. First one is the scalar multiplication. Another one is the scalar multiplication, another one is the vector multiplication. Scalar multiplication is generally known as the scaling. In the time of the scaling, we multiply the vector with a constant value. In the scaling, we multiply a vector with a constant value like 1, 2, 3, minus 1, minus 2, minus 3, any natural number. Vector analysis is again two types. One is called the dot product and another one is known as the cross product. What is the dot product? So now our main question is, what is the dot product? So according to the definition, the dot product, also called as the scalar product of two vectors in a number, is a number obtained by performing a specific operation on the vector components. So what is the dot product? Dot product, also known as the scalar product, if we multiply two vectors, if we take the two vectors, the result will come in a number, or the result is a scalar quantity. The dot product has the meaning only for pairs of vectors having the same number of dimensions. So we can tell if we are doing the dot product, so what will happen? The output must be a scalar quantity. So consider two vectors A and B. The angle between them is theta. For the sake of simplicity, we have represented them in the figure below. There is one A, there is one B, and the angle between them is theta. Then A dot B is equal to AB cos theta. We can give one more example on this. Say we have one force. Due to force, there is a displacement. So force and displacement both are the vector quantity. But while we are getting the work done is a scalar quantity. Work done doesn't have any direction. So we can write work done is equal to Fs cos theta. The work done is Fs cos theta. So this is the dot product. Then another product is the cross product. The cross product is defined as a vector C that is perpendicular to both A and B. We have three vectors, vector A, B and C. C is the output with a direction given by the right hand rule, and the magnitude of the area is the parallelogram of the vector span. So what is this? We have two vectors A and B. If we multiply the vector, this is known as the vector product also. The another name of the cross product is vector product also. So if we have vector A and B, the output will be the C, and we can calculate the direction of the C using the right hand rule or right hand screw rule. And we know that in this vector product, as the name implies, if we cross multiply or we do the cross product of the two vector, the output must be a vector. The output must be a vector quantity. So we can tell the cross product or vector product of two vector A cross B must be a vector, and that is perpendicular to the A to B plane, whose direction can be given. If A and B is this plane, C must be perpendicular to the AB plane, and we can give it from the right hand screw rule. And from the previous expression, it can be deduced that the if what is the A cross B? A cross B is equal to always the magnitude is AB sine theta. So if the two vectors are parallel, means if the theta is equal to 0 degree, we can tell that the magnitude is 0. If we can take the example of the Lorentz force, we know Q is equal to V cross B. So if V is the velocity, B is the flux density. When a motor is rotating in a magnetic flux, it will generate some force. So this force is it will generate some magnetic force. And now if the direction of the rotation, when it comes parallel to the electric flux, say it is rotating and this is the direction of the magnetic flux. So when the motor is in this side, there is some angle, but when it comes in the parallel to the B, the angle between these two is 0, and the magnitude and the force will be 0. So this is the cross product. Now we will define the point charge. Point charge, first of all, point charge is practically not feasible thing. We just for mathematical purpose or the calculation purpose, we use the point charge. So what is the point charge? A charge with smallest dimension on the body compared to the charges is called the point charge. Actually, there is not any definition of the point charge. But again, if we ask a charge with smallest dimension on the body, the charge with smallest dimension on the body compared to the charge, say we have a body, there are many charges are there. Which is the smallest one and whose with the smallest dimension is known as the point charge. A point charge is a hypothetical charge. As I told, that point charge is practically not feasible. It is a hypothetical charge located at a single point in charge. While an electron can for many purposes be considered a point charge. Sometimes we think that the one electron is a point charge because its size can be characterized by the length scale known as the electron radius. It is a very small one. So sometimes for one electron we think it is a point charge. But if there are many charges, maybe a combination of 2 electrons, 3 electrons, 5 electrons, we can tell them as the point charge. Point charge is always two types. Plus means positive and minus means negative point charge. And if you see the directions, sometimes it is the diverging nature. The electric flux coming from the positive point charge is the diverging in nature, and this is the converging nature. The flux coming to a negative charge is the converging in nature. Next, we will discuss about the permittivity. What is permittivity? Permittivity is basically two types. One is the absolute permittivity, another one is the relative permittivity. What is the definition of the permittivity? The ability of a substance or medium to store the electrical energy in an electric field. So we know in the capacitor, what is the use of the capacitor? Capacitor is used only to store the energy. So what is the why capacitor is store the energy? In between the capacitor there is some dielectric. In the case of the capacitor, between the two parallel plates, there is some dielectric medium. So, the dielectric medium helps to store the energy. Now, how much energy will be stored? It depends on the property of the dielectric. And which property? The property of the permittivity. The ability of a substance or a medium to store the electrical energy in an electric field. It is basically two types. One is the absolute permittivity, another one is the relative permittivity. Permittivity is written by epsilon. So what is the absolute permittivity? Absolute permittivity means the permittivity of air or free space or vacuum. And what is the value? 8.854 into 10 to the power minus 12. What is relative permittivity? Permittivity of any medium with respect to epsilon, not the absolute permittivity. And what is the total permittivity? Is equal to epsilon naught into epsilon r. So this is the permittivity. Define the electric field intensity. The definition of electric field intensity is a very basic question in the electrostatic field. What is electric field intensity? The electric field intensity at a point is the force experienced by a unit positive charge placed at the point. If there is an electric field and we keep one unit positive charge, how much force it will feel or how much will be experienced is known as the electric field intensity. Electric field intensity is a vector field and we assign with the symbol E. Units of the electric potential we generally takes as the volt per meter, but sometimes we take the units as the Newton per meter also. What is the equation of the electric field? Electric field is equal to Q by 4 pi epsilon r squared into AR. And from there we can write from the definition of the Coulombs force per Q. So the another unit is the Newton per Coulomb. The another unit is the Newton per Coulomb. The force experienced by unit charge. So force by Q. And always we will take as the positive charge. So I am moving to my next question. What is the electric flux density? So what is the electric flux density? Electric flux density or displacement density is defined by the electric flux per unit area. So as I told in the previous slides that from the positive charge, there are some electric lines of force which is in the outward direction or diverging direction, and for a negative charge it is in the converging direction. And what is the meaning of the electric lines of electric flux? Electric flux means if there is an electric field and if we keep any other thing near it, according to the line, it will feel some force. So this is also known as the electric flux, also known as the electric lines of force. So electric flux density or the displacement density is defined as the electric flux per unit area. So if the D is the electric flux, we can write D is equal to psi by S, and the unit is Coulomb per meter square or square meter. Where psi is the total flux and S is the surface area. And now for a sphere surface, the area is 4 pi r square. So what is D? D is equal to Q by 4 pi r square. Actually, from the Gauss law, we can write psi is equal to charge, number of electric lines of force is equal to charge enclosed is equal to Q. So psi is equal to Q. So in the D is equal to basically psi by S. So in there we can write Q by S or Q by A. A and S both are the surface area. S and A both are the surface area. So what is this? Q by 4 pi r square. So Q by 4 pi r square. And just previous slide we have discussed that the electric field intensity E is equal to Q by 4 pi epsilon r square. So what is the value of D by E? If we calculate D by E, we will get the value of epsilon. So D is equal to epsilon into E. Now, if the medium is the vacuum or free space, we can write that D is equal to epsilon naught into E. D is equal to epsilon naught into E. So this is the electric flux density. Name types of the charge distribution. So the types of the charge distributions are basically three types. One is the line charge, surface charge, and volume charge. Now one by one I will discuss what is the different types of the charge density. What are the different types of the charge distributions? So first one is the line charge. What is the meaning of the line charge? If there is an electric line and charge is along the line, this distribution is known as the line charge distribution. In the line charge distribution, we write the rho L. Rho L is equal to line charge density. And what is the meaning of the line charge density? If the total charge is Q by L, and what is the unit? Unit is the Coulomb per meter. Next, we will discuss about the surface charge. What is the surface charge density? Surface charge density means if there is a surface. So in a 3D, the number of surface is totally three types: XY plane, YZ plane, and the ceiling, the ZX plane. If we take any surface, then the surface has the charge in it. So if the total number of charge is Q, so Q by S is equal to the surface charge density. And what is the unit? Unit is the Coulomb per meter square. Now another charge is the volume charge density. Say if we take a volume, then there is a charge in any three-dimensional, and rho B is equal to volume charge density is equal to Q by B, and the unit is the Coulomb per meter cube. So we got three types of charge. Now, if we want to write it in a differential form, what will be the change if we want to write it in the differential form? In the differential form, rho L is equal to dq by dl. So what is q? Q is an integration of rho in dl along the line. If we write rho s, the surface charge density is dq by ds. So what is q? Q is equal to surface integral of rho s ds, or we can write it if it is an xy plane. So this is the xy. Rho s is equal to dx dy. It can be rho s is equal to dy dz or dz dx. So this, according to the surface integral will vary. If rho v, if we go to the rho v is equal to dq by dv, then what is the value of the q? Q is equal to volume integral of rho v dv. What is the meaning of the volume integral? It is a 3 times integral. Rho v dx dy dz. X, y, z along the x-axis, along the y-axis, along the z-axis. So this is the different types of charge distribution we have discussed: line charge distribution, surface charge distribution, and volume charge distribution. Now we will discuss about the Stokes Theorem. The Stokes Theorem is a very important theorem in the field of the vector algebra. So what is the Stokes Theorem tells? Stokes Theorem states that the surface integral of the curl of a function over a surface bounded by a closed path is equals to the line integral of the particular vector function around the surface. So what is the Stokes Theorem states? Stokes Theorem states that the surface integral of a curl of a function over a surface bounded by a closed path equals to the line integral of the particular vector function around the surface. The Stokes Theorem states that the surface integral of any function is equals to the volume integral of the divergence of same. So what Stokes Theorem still? Grad dot A of a closed surface ds is equivalent to the A dl. A dl. The surface bounded by a closed surface is equals to the A dl. Similarly, we can write grad dot A dv of a volume integral is equal to A ds. Stokes theorem can be used to turn surface integral through a vector field into the line integral. This only works if you can express the original vector field as the curl of some other vector. If we use the curl only, then only we can write the, if we use the curl vector only, we can use the Stokes theorem. Write the Maxwell's first equation. Maxwell's first equation is also known as the modified Gauss law, or we can tell it as the vector form of Gauss law. So what is the Maxwell's first equation tells? Maxwell's first equation has the two part. One is the point form. What is the point form? Point form we can find from the Gauss law. As I told in the Gauss law, psi, the number of electric flux, is equal to number of charge Q enclosed. And what is psi? Psi is equal to d dot ds surface integral of q is equal to psi is equal to d dot ds is equal to q. So q is equal to d dot ds. Now if we use the divergence theorem, as the output is a scalar, so we will not use the Stokes theorem, rather we can use the divergence theorem. Grad dot d is equal to dv. So again we know from the previous slide q is equal to rho v dv. So if we equate these two, we will get grad dot d is equal to rho v, and this is the Maxwell's first equation. What is the second equation? D dot integral form is q dot grad dot dv is equal to rho v dv is equal to rho v dv. Grad dot d dv is equal to rho v dv is the integral form, and grad dot d is equal to rho v is the point form. This also can be written in somewhere as the grad dot e is equal to rho v by epsilon, as d is equal to epsilon into e. So if we can use in the both form the value of the Maxwell's equation. Next question is the resolve the unit vector in terms of the distance vector. A unit vector is a vector that has a magnitude of 1 unit. What is a unit vector? Unit vector is a vector whose magnitude is 1 unit. Any vector become a unit vector by dividing the vector's magnitude as follows. Say if we have an x, y, z, so all the axis has the 1 unit vector, and the a dot is equal to a by mod a. So this is the a by mod a. This is the known as the unit vector. What are the different types of the coordinate systems? Coordinate systems is basically two types. One is the orthogonal coordinate system, another one is the non-orthogonal coordinate system. Orthogonal coordinate system is again can be non-orthogonal. Orthogonal means all the axes are perpendicular to each other. Non-orthogonal means which is not used in the perpendicular. For our normal problems, we use the orthogonal coordinate system. Non-orthogonal is used only for the space. So orthogonal system is basically three types. One is the rectangular or Cartesian, where we use the x, y, z axis. X, y, z axis. Another one is the cylindrical, and in the cylindrical axis we will use the rho, angle theta, and the height L. So rho, theta or L are we generally write by Z. Rho is the radius, theta is the angle of circle, and Z is the height. For a spherical means it looks like a ball. It is, if it is a sphere, so here we can find there is one radius r which is fixed, then the angle circle, so it is the theta, and the angle of the height, that is the phi, or generally we write this circle according to the middle. This is the phi and this is the theta. For the Cartesian coordinate, infinity is less than equals to infinity is equal to y is equal to minus infinity to plus infinity. The magnitude of the x varies from minus infinity to plus infinity. It is y is also minus infinity to plus infinity. Z is also plus infinity to minus infinity. This is for the rectangular or Cartesian. For the cylindrical coordinate, what is the value of the rho? Radius cannot be negative. So 0 less than equals to rho less than equals to infinity. What is the theta? Theta value is a circle. So it is 0 to theta is equal to 360 degree, or we can write it 2 pi. What is the z? Z or L? So it can be go in the negative also. So minus infinity z equals to plus infinity. For a spherical system, what we can write in the spherical system? For the spherical system, we can write, for the spherical system, one is r, one is theta, one is phi. So again, radius cannot be negative. So radius value is 0 to infinity. Phi, this angle between, according to the equator, so it is 0 to theta is to 2 pi. But in the case of the height, if it is a ball, from the height, we can write it is the 0 theta up to pi. So these are the range of the 3 coordinate system. Convert the Cartesian coordinate into the cylindrical coordinate. So first we will come to the relationship between the x, y, z. So if we are thinking about a cylinder here, we can think that the z is equal to z for the both case. What is x? X is equals to the r cos phi and y is equal to the r sin phi. Why? While we are thinking about the circle, about the lower portion of the x, this is basically the xy plane. This is basically the xy plane. And height is the z plane. So it is also the circle. It is also the circular layer of a cylinder, and on which we are drawing the cylinder. So if we are thinking the lower part of the circle, and this, if the angle between this, if the radius of this is, if r is creating an angle is phi, so what is the x? X is equal to always r cos phi, y is equal to r sin phi. So if we again add these two, x square plus y square, what is x square plus y square? X square plus y square is equal to r square cos square phi plus r square sin square phi. So it is the r square cos square phi plus sin square phi is equal to 1. So r is equal to x square plus y square. Similarly, if we divide the y by x, sin phi by cos phi is nothing but the tan phi. So we got r is equal to tan inverse y by x. Similarly, we can prove for the Cartesian coordinate also. Rho is equal to, rho radius is equal to root of x square plus y square plus z square. Phi is equal to tan inverse y square by z square. And the theta is equal to root of x square plus y square by z. State Coulombs law and write its application. Coulombs law states that the magnitudes of the electrostatic force of attraction and repulsion between two electrically charged bodies is directly proportional to the product of the charged bodies and inversely proportional to the square of the distance between from the center of the charged body. The inverse square relationship is also known as the Coulombs inverse square law. So Coulombs law is determined the force is attractive if the charges are of opposite sign. The force proportional to the product of the charge of Q1 and Q2 along the line joining them. If there is a charge Q1 and there is another charge Q2, force is always acts from the center of charge to another center of charge, and force is always works along the line joining them. Force is inversely proportional to the square of the distance. So we can write force is equal to 1 Q1 Q2 by 412 square. Or we can write force is equal to K Q1 Q2 by R12 square. So we can also write this in the vector form, that force 1 2 is equal to Q1 Q2 by 4 pi r square, 4 pi epsilon r square. This is the proportionality constant. This is the proportionality constant. And what is the direction? The direction is AR12. What is the meaning of AR12? AR12 means AR12 by mod of AR12. And this is the vector form of the Coulombs law. So what are the application? We can determine force for point charge, long conductors, infinite sheets, etc. from the Coulombs law. We can determine the intensity or field intensity and the potential of the electric field. We can also calculate the Gauss law and the Maxwell's law from the Coulombs law. So Coulombs law is the fundamental law of the electrostatics application. Define the potential difference and write its relevant expression. The electrical potential difference between 2 points in an electric circuit is the work done to move a unit positive charge from one point to another point. So, the electric difference V is equal to W by Q. The SI unit of the potential difference is volt and denoted by V. State the Gauss law and list out the 3 expressions. The electric flux passing through any closed surface is equals to the charge enclosed by the surface. Psi is equal to D dot ds is equal to charge enclosed, or we can write the define the electric field intensity. So electric field intensity already we have discussed in the previous slides also. Obtain the electric field intensity from the n charges. Here we use the superposition theorem. So what does the superposition theorem tells? If there is an electric field and there are the n number of charges Q1, Q2, Q3, Q4, we can calculate the electric field intensity as Q1 by 4 pi R1 square plus Q2 by 4 pi epsilon R2 square plus Q3 by 4 pi epsilon R3 square up to n Qn 4 pi epsilon Rn square, and this is known as the superposition theorem. Express the electric field intensity on the surface charge. So we know that the surface charge intensity E is equal to just we wrote Q by 4 pi epsilon R square. Now for the surface charge also we wrote before only that the surface charge Q, if we know the surface charge is equal to rho S ds for a closed surface. So we can write electric field intensity is equal to rho S ds surface charge by 4 pi epsilon R square. And what is the direction? Direction is the AR. Q by 4 pi epsilon per I square, and dq is equal to rho S ds. So we can write it like this. Express the electric field intensity of the volume charge. Same thing, E is equal to Q by 4 pi epsilon R square, and dq is equal to rho V dV. So what is Q? Q is nothing but the volume integration of rho V dV. So what is intensity? Intensity is rho V dV by 4 pi epsilon R square. Express the work done on the point charge of the in terms of electric field intensity. We know that the work done is always work done W is equal to force into displacement. We know work done is equal to force into displacement. So what is the work done for a charge? To move one unit positive charge from one point to another point, and this is for the one charge. So we can if we know the electric field intensity, so to move one charge it is E. What is E? E is equal to for force for one unit charge. So force into displacement. So what we can write? What is this? If we doing for the Q charge, now if we divide it by single charge, force into displacement, not into actually force dot displacement, force dot displacement by Q for a charge. So F by Q is nothing but the E into D. So work done is equal to E into D, and as it is bringing from far point to near point, D is always comes negative, and it is also known as the potential. So what is the potential? The work done to bring one unit charge from a far point to an electric field. State the Maxwell's equation. Already we have discussed the Maxwell's equation, that the rho v grad dot d is equal to rho v, and integration of d dot ds is equal to rho v dv. This is the Maxwell's first equation. And what is its relevance? It is we are getting from the modified Gauss law, or it is also known as the Gauss law in the vector form. So up to this we have discussed some important question. So up to this we have discussed some important questions on the electrostatics. In my next lecture I will discuss on the electrostatics, specifically capacitors and conductors. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.